Okay, so this is what this is the R Markdown document that I produced here. But if we were to go to CCLE, I'm going to log in. Okay, oh, my mouse is broken. This is the worst. Please. Okay. I hope it's not saving all of my passwords here. Okay, so then you come over here, and then oh my gosh, where is this? Okay, so I have the R Markdown. Alright, so here's the output, and I can just copy this over into Studio, and let me just delete all of this. I'm just copying and pasting it into here, okay? And now I'm very nervous that it's going to crash on me. It might. That's just part of programming. Things crash. So I'm going to choose. I don't want net PDF, I want net HTML. Undo this pop-up. Oh my gosh. This is very frustrating. No. Do you have a mouse?
Yeah.
Okay. Now let's try again. I can go left, but I can't go to the right. Let's see if we can do this. Okay, and this is the output. Wait for this to connect. But this is the output of the R Markdown file. Is this entirely new? Have you ever seen this before?
No.
Oh my gosh. Okay. All right. So anyway, what I've typed now comes out, and so the code that I've written, it designates. So I had this is plain text, this is code, and then the things that I've written in code that's supposed to produce output, it puts the output in there. Okay. So let's see here. Yeah.
So, if we want to create our own Markdown file, we just copy and paste the code that we wrote to the.
So I would start off with my R Markdown sample file, okay, which has the example from a different problem, and then I would just copy and paste that, and then replace all of my text and code with the code that you've created, okay? And so let me just show you what. Oh man, this thing is not. Okay. So just so you can see what the R Markdown file looks like. So you have to designate just a couple things. This just starts it off, and then this stuff I just type as plain text. Okay, so it says this is the sample lab. In this file, I'm demonstrating blah 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 blah, and that shows up right here at the top. This is the sample lab blah 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 blah. Okay, the stuff that is our code, I run here, and I say, okay, download this file and read the CSV file into this variable or data set cholesterol. And I have all of these commented out, meaning it's not being run. And then the first thing that is going to produce some output is head cholesterol. Did you learn about head? Mm-hmm. Okay, so head just shows you the top of the data file. And that's what we see here. Okay, so it runs the code up there. And then when after it says head cholesterol, it just shows that output. Okay, so notice that in my R markdown file, I didn't have to do anything. I just said run head cholesterol, and then I add this text. Okay. Yeah, sorry. It's thank you for letting me try your USB mouse, but apparently our computer just hates everything. So. So it says all of the, now I'm just writing text, okay? And so that stuff that I've written in text shows up right there, okay? And then the next thing and then I'm going back to code, okay? And the first line of code says levels, cholesterol, $ category, okay? And so, if we go back to the data file, we see that there's two columns. One is cholesterol, which shows us the cholesterol level, and category, which shows us whether the person was a smoker or an ex-smoker. And so when I ask levels, this lowercase cholesterol refers to the data set, not this column cholesterol. Okay, so this data set is lowercase cholesterol. $ category says, okay, look at the column category in the data set cholesterol. And then when I say levels, it says, okay, go through and tell me the unique categories that show up in that column. And it tells you, okay, the two unique categories that I see are ex-smokers and smokers, okay? And I ask for this because whenever I'm trying to make references in the future, I need to get the spelling and the case, everything matching exactly the same. Otherwise, R will say, I didn't find any of that. So I ask, just so I know exactly what it looks like, what are the names that you have stored in this thing? And I've got ex-smokers written this way and smokers written this way. Okay? So I tell R, okay, well I want you to create subsets of data. You learned about subsetting with bracket notation? Yes. Okay. And so I'm saying, okay, so I'm asking you to create a subset, and smokers.cholesterol is going to be a numeric vector. Okay? And what it's saying is take from the data set cholesterol, take the column capital cholesterol, okay, which is just the values, okay? But and if I stopped right there, it would just take that entire column. But I include this bracket, okay, and it says, okay, don't take every single one, but only take the values that match this criterion inside the bracket, okay? And the criterion inside the bracket says the category in dataset cholesterol must match smokers. And store those, so take this column where this criterion is matched and store those values into smoker.cholesterol, okay? And so this is just going to be a numeric vector, so just numbers, a list of numbers just for where it says smokers. And basically I do the exact same thing, except I do it for ex-smokers. Is that okay? So here I'm going to have just a list of numbers with the cholesterol levels of the smokers. I've got a list of numbers for the cholesterol levels of the ex-smokers, okay? And again, all of this just shows up with, so there's no output. If I type these into R, it would just accept and run those things without producing any output. Then I switch, so I'm designating the R code using this accent bracket R, okay? This designates R code, and then I do this and I say I'm done with the R code. And then here it's going to be plain text. And then now I'm doing, I'm designating R code again. And I'm saying the 2 bits of R code is I want you to give me a summary of that list of numbers, smoker.cholesterol, and give me a summary of the ex-smoker cholesterol levels. Okay, and we see when I ask for the summary, it takes each line that's going to produce code, and it says, okay, here's the code I'm running, here's the output. Here's the code I'm running, here's the output. Okay, so I didn't have to, like if you were to do this in a Word document, it would be time consuming because you'd have to copy this, and you'd probably want to indicate by a change of fonts or something that this is code that you're entering, and then you'd want to copy this and enter it and designate that this is output. Okay, so R Markdown is supposed to make your life easier by just allowing you to type these things directly and tell RStudio run this file, and it's going to produce all of this, change the formats for you, And if you need to make any changes, you can do it, and then it will update everything for you. Whereas with a Word document, you would have to delete things, repaste things, which is fine, okay? If you're okay with that extra manual labor, that's fine. I was trying to make your life easier, but apparently some of you guys are having trouble running R Markdown. Anyone successfully running R Markdown on their home PC or things like that?
Just one or like two? What do you say?
I mean, I don't know, just getting it to run without too many errors, yes.
She hadn't taught us the fact of, you know, the apostrophe brackets are and how to open and close, so that's why it wasn't working. But she never said to incorporate that.
Okay.
She just taught us codes like, oh, type this in and then you get this.
Okay, okay. So maybe, alright. Well, maybe there's a miscommunication on my part to her. Maybe I need to tell her specifically go over R Markdown. Yes?
Yeah, in our lab this week she said that she thought we were no longer being taught Markdown because it wasn't working before.
Okay, so alright. Yeah, I guess
we didn't get taught it yet.
Misunderstanding. Okay, so let me just tell you, when you run R Markdown, you should be able to copy my code and then copy it. So when you go to RStudio, oh look, my mouse is, oh, okay. You're going to go, you know, File, New File, and you're going to choose R Markdown, okay? And it's going to produce an empty one, okay? And it will probably have some of these things designated, and then you would just type stuff in, okay? So let's. Okay, so this is it. Okay, so here's, and it actually gives you some stuff to begin with, and then at the top you would go to knit HTML. There's got to be something actually, okay? And then you click knit, and it knits it for you, okay? And so you can look at the code in the when you start a new blank document, it actually populates it with stuff, and you can look at the this thing. Yes.
When we're writing the code on RStudio, do we write it in like the first tab or like the bottom tab?
Okay, so RStudio, there's like 4 panels and stuff. This top. This top area, these are for files, okay? This down here is the console. So you go to the console, you type something in, it immediately runs it, and it produces your output, okay? Which is probably what you guys have been doing, I imagine, okay? That's fine and all, except if you ever do research or anything like that, you're working on a report, you probably want to keep a record of the things you've done, and you can go do that by going to the history and things like that, okay? If you work in a file right here, you can type your code, and then you could tell R, run this code, or run this section of code, and then basically sends that stuff down to the console, and you can see how it runs. And then that way you don't have to constantly have to retype. I imagine, so usually when people learn R, they start off with the console, and that's the place to start, okay? But I imagine you might have typed something in, and then you realize, oh, I made a small mistake, or, oh, this isn't exactly what I want to do, and you have to either retype the entire line, or you hit the up button to get the last thing again, and you can make some changes, and then later on you're like, oh, and then it works, and you're like, oh, that was great, but then later on you want to make another change or something, and you have to go cycle through and search for all of these things, okay? If you just keep like a document open, just a blank R script, okay? You can just run code here. So you can say like data set. I want to do read.csv, you know, and open I don't know, something baseball.txt, and then you can say. Learn the keyboard shortcuts, but normally the mouse works just fine, and then you can just run the thing, and it runs it, okay? And then later on you're like, oh wait, you know, I need to do this and that. You can change your code up here, and then hit run, or highlight the codes that lines that you want to run, and then you click Run, and then it copies it down into here and it runs it. Okay. All right. So anyway, R Markdown. Maybe I did not communicate this clearly to Romalyn, but basically you're just going to run these things. You designate the R stuff with the accents bracket R that says this is the beginning of R code, and then this designates the end of R code. And that way you can transition between plain text where you're adding your commentary and explanation of what we're looking at, because nobody wants to just see a bunch of R code and output. Okay, that's not useful. So usually you'd run some R code, have some output, and then you'd add your commentary and say, in this output we can see this. In this output we can see this. And that's what I tried to do with this this file. Okay. And then so, I just added a few things. They say, from the summary statistics we see blah, 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 blah. Okay, and then I've created a histogram, and this is the histogram of cholesterol levels for the smokers, and here's a histogram for the cholesterol levels of the ex-smokers, and then I add some commentary, and then here's the box plot and things like that. And then this is where I was going to give you the instructions that said this is what you need to do. Okay, this is the HTML output. You can do knit a PDF, and it changes everything to a PDF. You could knit it as HTML and then print or save it as a PDF. That's fine. It doesn't really matter. But that was what you're supposed to do. If it doesn't work on your computer, you can do the copy and paste method with Microsoft Word. And if you're more comfortable with that, that's fine. Okay. That's how I started writing R labs and things like that, okay? But I realize, if you are able to get the R Markdown to work, I think you'll find that it's more streamlined and easier to use this method. Now there's a few, I guess, caveats or just warnings, is that sometimes you'll have code working in the console, but then you copy it into R Markdown and it doesn't seem to work, okay? And that's especially true with things where you're making calls to the internet. Okay, so here I said download the file and read it. I executed those commands within the R Markdown file. If you're running into trouble, I gave another set of commands. And sometimes one set of commands works better on the PC versus a Mac, and and vice versa. And sometimes they just don't work, things like that. If you go online and you search for why isn't this thing, or I'm getting this certain error, you're going to see all sorts of stuff, and nobody fully knows why. Computer things get weird and stuff. So you might find it easier to just download the file locally and then load it in RStudio. And did you learn about setting your working directory and things like that? Yes? No? Okay, so there's set WD and get WD. And basically, so when you open up R, it defaults and it says, I'm going to look in this directory for all of the files that I'm working with. Okay, and so generally it defaults to your documents folder, or maybe a documents/RStudio folder. That's where it defaults. And basically, when you download files, you want to put it into that directory. Or if you don't save it in that directory, you want to tell R, look in this directory. And you call that your working directory. Okay. So just, if you have trouble downloading and loading the file into R, go on Google and type in R working directory, and it'll teach you the commands that you need to know, okay? So yes, there is also some level of expectation where if you run into problems, you're going to use the internet and Google to help search for some of your answers, okay? Of course, it's not meant to be so incredibly hard that you hate everything, but there's supposed to be a little bit of challenging, okay? This lab is due on Monday, okay, and make sure you turn your files in through CCLE. So I asked Roman Lynn to just accept the emailed labs for this first one because maybe it wasn't clear. But from now on, all of your labs need to be turned in through CCLE, and that's that. Okay.
Question?
Yes.
So this is R Markdown, right? And
So
if
this
you-
is
yeah.
R Markdown, and then you click the knit button, and it turns your R Markdown file into nice output.
So for your output, can you hide the code and only output
Yes.
the?
Yeah. In
So when you hit the
So-
output button and it's pop up web page, right? And you have a gray box which is.
Yeah, so if you want to hide the code, so it defaults to, if you've typed in R code, it's going to show you the R code that you typed in, and then it's going to give another box that shows the output. And then and it does that line by line. If you, for whatever reason, you want to hide the code that you've written, there's an option inside the bracket R, you would type in echo equals false. Okay, echo means show what you've just.
So comma echo.
So I think in the blank document there's an example. Okay, so in this case it says if you run summary cars, it's going to do that, and then in this case it says echo equals false, and that says don't show this line, just show the output. Okay.
Thank you.
If you want to hide, and then it gives you even the explanation here. So that's R Markdown. And you can even go somewhere on, you go to YouTube and you say R Markdown tutorial. There's going to be too many videos to go through, but there will be a lot of videos that if you have the time and patience to go through, you can watch those and they'll give you an idea of stuff. Okay. And again, if you can't get the R Markdown to work, you can do the copy and paste into Word and accept and do that. Okay. Is that okay? All right. Do we hate these labs and everything, or are they okay? You hate them with a passion. All right. Well, that is unfortunate. Oh, okay. So now I have 20 minutes to cover stuff from Chapter 7. But I think that's okay. Okay. So we have a test on Friday. It covers up through what we did yesterday, Chapter 6 with the normal model. Has anyone? How did the Chapter 6 normal model stuff go? Everyone okay? Okay. So it covers up through that. I'm looking at the test. In my mind, I feel like this test is way too easy. I don't know. We'll see. All right. Huh?
Leave it like that.
Leave it like that. I feel like if you can read, it's gonna be fine. Okay. Well, I don't know. Okay. I hope you feel like you've learned a little bit, or maybe all of this beginning stuff has been review. But I'm hoping you have. If you flip to the end of the book, you should be able to say. You should say, I don't know how to do this, and I hope at the end of the course you could say, I know how to do this, and it's easy. But and if that's the case, I feel like I've done my job. All right, so Chapter 7. We're moving on. Chapters 1 through 6 were all about describing data, describing variables. We talked about categorical variables, and we spent a good amount of time on numeric variables with describing numeric variables, summarizing them, and if they fit the normal model, using that further information to give us even better descriptions or understandings of the data. With chapters 7, 8, 9, and we are skipping chapter 10, but that's also related, we are looking at two numeric variables at a time. We're looking at the relationship between two numeric variables. So we might look at the relationship between the height of a person and the weight of this person. we might look to see if there's a relationship between you know, the age of someone and the age of the spouse. Okay, these are numeric variables. We might look at I don't know, the height of a man versus the height of his father. Okay. And the tool for exploring, the basic visual tool for exploring relationships between two numeric variables is the scatter plot. All right. And I think many of you are familiar with this. If you've ever used Excel or something, you might have generated a scatter plot. All we're doing is we're taking the data points, each of the cases in a data set such as this will have at least two numeric variables, okay? So if we look at, if we're looking at this example, okay, each case is a person, and we would have one numeric variable, which would be the man's height, and then another numeric variable associated that would be the height of his father. Okay, so we'd have the person, you know, and then his height and the father's height. And so, you know, if we look at Joe, maybe he is 70 inches tall and his father was 68 inches tall. Okay, and we might have more and more data such as this. And on our scatter plot, we would graph (70, 68). And for every data point, or every case in our table, we would add, you know, dots indicating that data point, okay? So we're just plotting coordinate pairs. Let me adjust this. No, you're fine. Does that make sense? Okay. Okay, and we would see an overall trend. Okay. Overall, the trend that we would see between a man's height and his father's height, the general trend would be generally men who are taller than average have fathers who are taller than average. Men who are shorter than average, in general, have fathers who are shorter than average. Of course, that's not always going to be the case, but that will be the overall trend that we would probably see. Okay, so the overall trend, oops, overall trend, taller men will generally have taller fathers, have shorter fathers. Whenever you have a relationship where high values of one variable are associated with high values of the other variable, as in this case, so men with high values for height have fathers with high values for height. So if high values of one if high is matched with high for variable 1 and variable 2, and low is matched with low, in general, we would say this is a positive relationship. So actually, all three of these examples are examples of positive relationships. In general, we expect tall people to weigh more, and in general, we expect shorter people to weigh less. In general, if somebody is old, we expect his or her spouse to be older. If somebody is young, we expect his or her spouse to be younger. Okay, so high values are associated with high values, low values associated with low values. In general, okay, of course, there's always going to be exceptions to these things. But if overall the trend is high goes with high and low goes with low, that's a positive relationship. On the other hand, a negative relationship, high goes with low and low goes with high. This is a negative relationship. Okay. Can anyone think of two numeric variables that might have a negative relationship? Okay, so a few examples. We could look at altitude and air pressure. So in general, places of high altitude will have low air pressure. Places with lower altitude will have higher air pressure. Okay, so negative relationships. Okay, so altitude versus air pressure. Okay. Maybe outside temperature. So that's a numeric variable. Versus number of sweaters sold at a clothing store. So on days with high temperature outside, they're probably not going to sell a bunch of sweaters. They're going to sell few sweaters. On days with low temperature outside, they're more likely to sell more sweaters. Okay, so high is associated with low, low is associated with high. If we were to plot a scatter plot, make a scatter plot for negative relationships and plot the points, it would probably look something like this. Okay, so negative relationships go in this direction. Positive relationships, in general, go in that direction. Another aspect of a relationship between two numeric variables that we want to talk about and mention is the shape of the relationship. Okay, so we've talked about positive and negative relationships, but we also have shape. Okay, and shape, we're just going to make two categories of shape. We have linear relationships and those that are not linear. Okay, it's a nonlinear. If in a more advanced statistics course, you might expand on nonlinear relationships and have exponential relationships or quadratic relationships or different types of things, but we're just going to make the split between linear and nonlinear. Linear basically means straight line. If a straight line can form kind of a summary, then it's a linear relationship. Okay? So right here, this is a linear relationship because it looks like a straight line could fit our data. Over here, nonlinear would just be anything not a straight line. All right. So basically, if your data looks like this, you're going to say it's nonlinear. There might be a lot of scatter. Okay, we got a cloud of points. But overall, if you can kind of draw a cloud of points and draw a straight line through it, linear, that's fine. Okay, if there's a clear pattern where it's not going to be straight, these would be nonlinear relationships. Okay. Everything we're going to learn in chapters 7, 8, and 9 apply only to linear relationships. So if you're faced with a data set outside of your textbook, or I guess technically there will be examples in the textbook, your first step should be, if you're looking for a relationship between two numeric variables, your first step should be create a scatter plot and make sure that the relationship looks linear, or at least kind of linear. Because otherwise, the stuff we're going to learn will not apply. Did you have a question? Okay. So your first step should be make a scatter plot and just check the shape. Is it linear or nonlinear? So, I don't know. Step 1, make a scatter plot and check the shape. And if it's linear, then you can continue on with the step we're learning. Otherwise, it does not work. Or worse, technically these things will produce values and produce results, but in the worst case, your interpretation and understanding is just going to be wrong. So we've talked about the shape. We've talked about the direction, positive or negative. We also have to talk about the strength of a relationship. The strength of a relationship can be weak, it can be strong, and anything in between. Medium, moderate, okay? Strong relationships will have little scatter in the scatter plot. Little scatter will fit very closely to a straight line. And allows you to make good predictions based on one variable. Weak relationship, pretty much everything just the opposite. Lots of scatter. Okay, points deviate greatly from a straight line. Okay, and predictions will not be as good. Not as accurate. Okay, so this would be an example of a weaker relationship because there's quite a bit of scatter. This would be a very strong relationship, if not perfectly strong. But rarely will you see data looking like this. Okay, you'll see if you have something like this, this is still would be considered strong. Just a little bit of scatter, things like that. I know I'm kind of going quickly, but I feel like these are simple enough concepts that we're able to keep pace. At least you guys are. I just taught the same class, not the same class, but similar topic last night.
Where?
UCLA Extension, but it's mostly like community college students. And it was a little rough. I shouldn't talk about my other classes. It's like saying bad things about your kids to each other. Okay, so we've got strong relationships and weak relationships, positive relationships, negative ones. Okay. In the previous chapters, we learned about summary statistics, such as the range and the IQR and the standard deviation to give us an idea of spread. We learned about the mean and the median to give you an idea about the center. We have the same thing here, except it's just the symbol R for correlation. Sometimes the full name correlation coefficient. This is just a summary statistic that tells us whether something is positive and the strength. Okay, so I'm sorry, not what. It tells us the direction and the strength of a relationship. Okay. Okay, what does it not tell us? The shape. Okay, so when describing a relationship, we need to know the shape, the direction, and the strength. R does not tell us the shape. Again, right now, the only way for us to check shape is to create a scatter plot. Okay, so it does not tell us shape. And for non-linear relationships, R is not meaningful. So you can have correlation would exist. You can just stick it in the formula or throw it at a computer and say, calculate the correlation for me, and it will produce a value, but it won't necessarily be meaningful. Okay, so I'm like running out of time, but basically, let me just write this last thing. R can be anything between 1 and -1. If R is equal to 0, then you have no relationship. Okay, R is positive. That means a positive relationship. And R is negative. You have a negative relationship. Okay, so that's simple. The sign of R is the sign of the relationship. If R is close to 1 or -1, it's strong, okay? To 1 or -1, you have strong relationship. And if R is close to 0, you have a weak relationship. Okay. Simple enough. Very simple. You have some exercises in your homework. The homework that I assigned tonight will be due on Monday, okay? So between now and Friday, just focus on studying. And to study, I would just review all of the problems that I've assigned. I feel like if you can do all of those, you should be okay for the exam. Yes? Test goes from chapters 1 through 6. 1 through 6. Okay? Yes, another
Is
question.
the note card front and back, or?
Yeah, the note sheet is front and back. I'm making this way too easy for you guys with the note sheet and everything, but it'll be fine. Yeah.
Will there ever be any R coding on the test?
No R coding on this test, okay?
Oh, well, no.